Have you ever looked up at a plane soaring through the sky and wondered how something so heavy could stay aloft? The science behind flight is fascinating, and understanding it enhances our appreciation for this incredible feat of engineering. From the four fundamental forces that govern flight to the intricate design of airplane wings, we'll explore the principles that allow us to travel thousands of miles across the globe. Understanding how planes work allows us to appreciate the ingenuity and creativity of the inventors and engineers who made flight possible. It also helps us grasp the complexity of modern aviation, from the powerful engines that propel aircraft to the sophisticated navigation systems that guide them. So buckle up and get ready to take off on a journey into the world of flight. Four primary forces are at play when an airplane is in the airlift, thrust, drag and gravity. These forces work together in a delicate balance to keep the airplane in flight, each playing a crucial role in the dynamics of aviation. Lift is the upward force that counteracts gravity and keeps the plane from falling back down. It is generated by the wings of the airplane as they move through the air, creating a difference in air pressure above and below the wings. Imagine holding a kite in the wind. The wind provides lift, keeping the kite up. Similarly, the wings of an airplane are designed to create lift by manipulating the airflow around them. Thrust is the forward force that propels the plane through the air. This force is typically provided by the airplane's engines, which generate the necessary power to move the aircraft forward. Think of a boat's motor pushing it through the water. The motor provides thrust. In the same way, an airplane's engines push it through the air, overcoming the resistance of drag. Drag is the force that opposes thrust, like the resistance you feel when you try to push a heavy object across a rough surface. It is caused by the friction and pressure differences as the airplane moves through the air. In flight, drag is caused by air resistance. Engineers work tirelessly to design aircraft that minimize drag, allowing for more efficient flight and better fuel economy. Finally, gravity is the force that pulls everything towards the center of the Earth. It is a constant force that acts on the airplane, pulling it downward. It's what makes a ball fall back down when you throw it up in the air. Gravity is always at work, and pilots must constantly manage it to maintain control of the aircraft. For an airplane to fly, lift must be greater than or equal to gravity, and thrust must be greater than or equal to drag. This balance allows the airplane to ascend, cruise, and descend safely. When these forces are balanced, the plane can maintain a steady altitude and speed. Pilots and engineers work together to ensure that these forces are managed effectively, allowing for safe and efficient flight. Understanding these forces is fundamental to the science of aviation and the art of flying. Airplane engines are responsible for generating the thrust needed to move the plane forward. These engines are marvels of modern engineering, designed to convert fuel into the immense power required to lift and propel these massive machines through the skies. They do this by taking in air and mixing it with fuel. The process begins with the air intake, where large volumes of air are drawn into the engine. This air is then compressed and mixed with fuel in precise proportions to ensure optimal combustion. This mixture is then ignited, creating a powerful explosion that forces hot gases out of the back of the engine. The ignition process is a critical phase where the fuel-air mixture is set alight, resulting in a rapid expansion of gases. These hot gases are expelled at high speed, generating the necessary thrust. This expulsion of gases creates a forward thrust, propelling the airplane through the air. The principle behind this is Newton's third law of motion. For every action, there is an equal and opposite reaction. As the gases are pushed out, the airplane is pushed forward. There are two main types of airplane engines, piston engines and jet engines. Each type has its own unique mechanism and application, suited to different kinds of aircraft and flight requirements. Piston engines are similar to the engines found in cars, using pistons to move a crankshaft that turns a propeller. These engines are typically found in smaller aircraft and are known for their reliability and ease of maintenance. Jet engines, on the other hand, don't have propellers. They are designed for higher speeds and greater efficiency at high altitudes, making them ideal for commercial airliners and military jets. Instead, they use a series of fans to compress air, mix it with fuel and ignite it, creating a continuous stream of hot gas that propels the plane forward. The fans play a crucial role in compressing the air, which increases the efficiency of the combustion process. The power of an engine is measured in horsepower or pounds of thrust. Horsepower is a measure of the engine's overall power output, while pounds of thrust specifically measures the force generated to propel the aircraft. Larger airplanes typically have more powerful engines to generate the necessary thrust to get them airborne and keep them flying. These engines are capable of producing thousands of pounds of thrust, ensuring that even the heaviest aircraft can take off, cruise at high altitudes and land safely. Pilots rely on these powerful engines to maintain control and ensure a smooth flight. The engine's performance is constantly monitored through sophisticated instruments in the cockpit, allowing pilots to make real-time adjustments as needed. Regular maintenance and inspections are crucial to keep these engines running efficiently and safely. Engineers and technicians work tirelessly to ensure that every component is in perfect condition, minimizing the risk of mechanical failure. From takeoff to landing, airplane engines play a vital role in the journey, ensuring that passengers reach their destinations safely and on time. The next time you board a flight, take a moment to appreciate the incredible engineering that makes air travel possible. The shape of an airplane's wings is crucial for generating lift. Without this specific design, airplanes wouldn't be able to take off, stay in the air, or land safely. Airplane wings are designed with a special curved shape called an airfoil. This design is not arbitrary. It is the result of extensive research and testing in aerodynamics. This shape is thicker at the front, known as the leading edge, and thinner at the back, called the trailing edge. The gradual tapering of the wing is essential for managing airflow. When air flows over the curved upper surface of the wing, it has to travel a longer distance than the air flowing under the flatter lower surface. This difference in travel distance is a key factor in generating lift. This difference in distance creates a difference in air pressure. The concept is rooted in Bernoulli's principle, which states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure. The air flowing over the top of the wing moves faster and creates an area of low pressure, while the air flowing under the wing moves slower and creates an area of high pressure. This pressure difference is what generates lift. The higher pressure underneath the wing pushes the wing upwards, creating lift. This lift force must be greater than the weight of the airplane for it to ascend. The angle at which the wing meets the oncoming air, called the angle of attack, also affects lift. Pilots can adjust this angle to control the amount of lift generated. Increasing the angle of attack can generate more lift, but only up to a certain point. Beyond this point, the airflow can no longer smoothly adhere to the surface of the wing. If the angle of attack is too steep, the airflow over the wing can become disrupted, leading to a loss of lift known as a stall. Pilots are trained to recognize and recover from stalls to ensure the safety of the flight. The principles of lift have been understood and applied since the early days of aviation. The Wright brothers, for instance, meticulously studied wing shapes and angles to achieve their first successful flight. Modern aircraft are equipped with advanced control surfaces like flaps and ailerons, which help manage, lift and control the aircraft's attitude during different phases of flight. Understanding how wings generate lift is fundamental to aviation. It not only allows for the safe takeoff and flight, but also ensures a smooth and controlled landing. Pilots rely on their knowledge of aerodynamics and the principles of lift to make informed decisions during flight. This understanding is crucial for navigating through different weather conditions and handling emergencies. In turbulent conditions, the principles of lift and the design of the wings help stabilize the aircraft, ensuring a safer and more comfortable flight for passengers. The marvel of flight is a testament to human ingenuity and the understanding of complex aerodynamic principles. Every time an airplane takes to the skies, it is a celebration of these scientific achievements. So the next time you look out of an airplane window, remember the incredible science and engineering that keep you soaring through the skies.